All right, picking up where we left off from the last video. So far we've been learning that there are many things going on behind the scenes when creating programs and when programs run. Um, and they may not all work on different platforms or different machines. Most of the work has been done for us, but still, if you run into an issue, there could be a variety of different reasons. Especially if you write a program or a game or an app or whatever it is and stuff, and it doesn't seem to work on every platform. Um, this is also a very good idea to have it possible so that people can leave comments for developers saying that this won't work this way, this won't work that way, that way. The developers can see it and try to make corrections so that the program does work on more platforms, more machines, more architectures. Continuing where we left off, we were currently discussing this and learning more about what this tutorial has to offer, as well as what we create and possible issues we could run into besides just our code itself, and how to fix these issues. So let's continue. In these tutorials, we will avoid platform-specific code as possible, as much as possible, so that programs will run on any platform that has a modern C++ compiler. High-level languages have other benefits as well. Programs written in a high-level language are easier to read, write, and learn because their instructions more closely resemble the nature language and mathematics that we use every day. In many cases, high-level languages require few instructions to perform the same task as low-level languages. For example, C++, you can write A is set to B times 2 plus 5 in one line. In assembly language, this would take 4 to 6 different instructions. So 4 to 6 different lines of code to get that to work, go from what you can see and type into a text editor. And then if you were to build the actual translator in an assembly language, and yeah, there's a lot to just to get that little bit of code right there to work from C++. This makes program writing programs written using high-level languages more concise, which makes them easier to understand. High-level languages typically include additional capabilities that make it easier to perform common programming tasks such as requesting a block of memory or manipulating text. For example, it only takes a single instruction to determine whether the character ABC exists within a large block of text. And so, and if so, how many characters has to be examined under ABC was found. Make sure I'm reading that right. And if so, how many characters has been examined under ABC was found. I'm not sure if I'm reading that right, but this can dramatically reduce complexity and development times. And yes, it does. Could you imagine if people before us did not write compilers, interpreters, the software, the components? I mean, what they went through back then just to get a simple program to work. First, writing the code. Second, compiler. Third, the interpreter for different computers, or the interpreter for your own computer even. How much time that would take just to write all that code for one simple program to be able to work. And then you can understand the complexity of what it takes for any program you download and run, game, app, etc., for it to work. How much development time may have gone into it for that to work. Um, and yes, I do recall watching some videos of people that just simply sat in an office, slept in an office, ate in an office, and all they did all day long for 8 to 16 hours a day was just simply write code for these specific things. Yeah, that's quite a bit. I've never been able to pronounce this word here. Nomenclature. Yeah. Never been able to pronounce that word very well. I need to look it up to figure out how to pronounce it properly. Anyways, although C++ is a is technically considered a high-level language, new programming languages like scripting languages provide an even higher level of abstraction. As such, C++ is sometimes inaccurately called low-level language in comparison. Now, remember, this information that I'm reading was designed or built by an individual, so I don't know where he's getting his information from, but so far it's been quite helpful to me. Um, but yes, it may be considered that C++ is a low-level language just because it requires C++, script languages, multiple languages for some programs to work. So when you're using multiple languages for some programs or applications or games or whatever to work, um, all the different programs that were written prior to that or prior to those programs. So this, uh, it's probably simpler than what I'm making it sound to be, just because I don't understand it. Um, but yeah, I imagine a lot of work went into making things today possible. Here's an author's note. Today's C++ would probably be more accurately described as a mid-level language. However, this also highlights one of C++'s key strengths. It often provides the ability to work at different levels of abstraction. I can say the word, I just can't get it out of my mouth. You can choose to operate at low level for better performance or precision, or at high level for greater convenience and simplicity. So yes, I guess C++ can be both a high level and a low level depending on what you're using it for. Most of the time C++ is something that's done in the background and stuff for things to work, just like scripts, where most of what you see is graphics or websites. Anyways, rules, best practices, and warnings. As we proceed through these tutorials, we'll highlight many important points under the following three categories. Rules. Rules are instructions that that you must do as required by the language. Failure to abide by a rule will generally result in your programming not running. Best practices are things that you should do, because that way doing things in either conventional, idiomatic, uh, or recommended. I'm guessing I'm pronouncing that right. That is, either everybody does it that way, and if you do otherwise, you'll be doing something people don't expect, or it is generally superior to the alternatives. So, uh, in a sense, that kind of works both ways, I think. If you do the same thing everybody else does, then things tend to progress. But if you do something unexpected, it can end up triggering unknown results. And that's not just with programming. People come up with creative ways to do things and stuff, and so they try them out. And whether they succeed or fail in that, it could end up sparking inspiration or creativity on somebody else's behalf to do something that is very unique, um, in a sense, kind of thing. And then warning, these warnings are things that you should not do because they will generally lead to unexpected results. Yes, there are some things in C++, compiling, all that sort of stuff, programming and stuff like that, that if you don't understand it, you probably shouldn't do it yet until you've fully researched it and fully understand it, so you know what's going to happen when you end up doing things. Not uh, not using caution or warning when doing things can result in not only programs that not work, but also issues with your machine, and a lot of unknown variables. So let's move on to the next part here. Introduction to C and C++. Before C++, there was C. The C language was developed in 1972 by Dennis Ritchie at Bell Telephone Laboratories. I don't know if anybody remembers Bell. I do. It was a telephone company for landlines. I think it got bought up by, eventually got bought up by another company, and then I think Bell ended up coming back and bought up that company again. But I'm not sure. I can't remember. But yes, I do remember Bell. Primarily as a system programming language, a language to write operating systems with. And then Ritchie's primary goals were to produce a minimalistic language that was easy to compile, allowed efficient access to memory, produced efficient code, and was self-contained, not uh, reliant on other programs. For a high-level language, C was designed to give the programmer a lot of control, while allowing developers to write a program that could be run on different platforms. Because yeah, back then there wasn't a whole lot of different computer systems out there. There was, but not a lot, not like there is today. C ended up being so efficient and flexible that in 1973, Ritchie and Ken Thompson rewrote most of the Linux or Unix system operating system using C. Many previous operating systems had been written in assembly, unlike assembly, which provides programs that can only run on specific CPUs. C was excellent, portable, allowing Unix to be easily recompiled on many different types of computers and speeding its adaptation. C and Unix had their fortunes tied together, and C's popularity was in a part tied to the success of Unix as an operating system. I don't remember Unix myself very well. Um, Back when I was a young child, the only thing I remember was DOS. But computers for me and stuff wasn't really too much of an option because computers actually were quite expensive. Um, Much more expensive what they are now, in a sense of the time. Um, Back then, a computer could cost you anywhere between $500 and $1,000, and that was when minimum wage was like $5.25 an hour. So it might take you a while to save up enough money just to buy a single computer, and you couldn't do a whole lot on it. You had to write the code yourself. You had to write everything yourself to get the program to work. In fact, when you bought a computer, um, it might come with a floppy disk, uh, or you might have to buy it separately, and that's for a game to work. Again, when I was really young, I didn't understand anything about computers at all, very little bit. Anyways, moving on. In 1978, Brian, I can't pronounce his last name, and Dennis Ritchie published a book called The C Programming Language. This book was a commonly known as K&R after the author's last names, provided an informal specification for the language and became a de facto standard when maximum portability was needed. Programmers would stick to the recommendations in K&R because most compilers at the time were implemented to K&R standards. Um, so yeah, when you have limited options and stuff, you kind of have to stick to one thing until you understand compilers, and you could rewrite the compiler at the time, uh, or write new compilers and stuff so it would do more than what it was originally designed to do. In 1983, the American National Standard Institute, ANSI, formed a committee to establish a formal standard for C. In 1989, uh, committees take forever to do anything. They finished and released the C89 standard, more commonly known as ANSIC. In 1990, the International Organization of Standardized ISO adopted ANSI C with a few minor modifications. This version of C became known as C90. Compilers eventually became ANSI, CS, or C90 compliant. The programs desiring maximum portability were coded to this standard. So yeah, limited options made it hard to do things. So you had to there was a lot of experimenting. A lot of things nowadays didn't exist, which we already know that. But this is just kind of more of a history lesson, which is something I haven't read through yet. So in 1999, the iOS committee released a new version of C, informally named C99. C99 adopted many features that which had already made their way into compilers as extensions or had been uh, implemented in C++. C++ was developed by I can't pronounce his name ever. I've seen his name many times at Bell Labs. I didn't know he worked there. As an extension to C, starting in 1979, C++ added many new features to the C language and is perhaps best thought of as a superset of C, though it was not strictly true, as C99 introduced a new feature that does not exist in C++. C++'s most notable innovation over C is that it supports object-oriented programming, which we discussed that in my other source of information, OOP. As for what an object is and how it differs from traditional programming methods, uh, we'll cover that in later chapters. C++ was standardized in 1998 by the ISO, which I'm pretty sure that that company right there, ISO, is still around now, and I believe they are the ones that pretty much um, keep C++ up to date or kind of control it or whatnot as far as what's in the language and what's not. And that's just the standardized. Obviously, if you know how to write code and a more complex, or not complex, but lower levels or whatnot stuff, then you can rewrite it to match your own needs. So if you understand the different levels of programming, compiling, interpreting, translating, etc., um, and you know how to read all that code right there, you could probably rewrite your own code to do specific things you want it to do. That is a very complex understanding of how to get a program to do specifically what you want it to do without limitations. So let's see here. This means iOS Standard Committee approved a document called Standard Document that provides a formal description of C++ language, which I'm pretty sure that is now called the CPP Reference Guide. I'm pretty sure, but not positive. The goal of standardization is to help secure the C++ code behaves consistently across different compilers and platforms. So no, I was wrong on that. A minor update to the language was established in 2003 and formally named C++03. 5 major updates in C++ language informally named C11, 14, 17, 20, and 23. Now there's 26 is coming out. Have been made since then. Each adding additional functionality. Um, 11 in particular added a huge number of new capabilities and is widely considered to be a new baseline version of the language. Future upgrades to the language are expected every 3 or so years. So yes, when you have to do updates, phone, tablet, computer, whatever it may be, most of the time it's because the languages for compilers, for programs, for whatever it may be, have changed. Uh, Most of the time for the better, but sometimes to make it easier, take up less space in the RAM, more better performance sort of thing right there. So it's meant to continuously improve overall. Moving on, because the official name of the approved standard in complex is complex, C plus 20's formal name of ISO or IEC. I don't know what either one of those are. And then we got a number right there. I'm not sure what that is. Standard is conventionally referred to it by formal names, which include the last two digits of the year published. Um, so yes, yeah, I don't know where to go with that one. For example, C++ 20 refers to the version of the language published in 2020. Okay, so yeah, the last two digits just refer to the year. C and C++ philosophies, the underlying design philosophy of C and C++ can be summed up as trust the programmer. Trust the programmer, maybe not trust all programs. And I am not 100% sure I really want to trust the program so much. It is best to look into reviews on stuff. If there's no reviews on anything, on something you want to download and stuff, then whether the good reviews or bad reviews, it's might be iffy to download the program. So let's say you found an app or a game and stuff you want to download, and you're literally the first person to download it. In the case of you downloading the program, you are essentially trusting the programmer to have written the program properly. It'll work on your system, and it won't tear up your hardware. um, And then once you do that and stuff, if you know how to operate your computer and stuff in any sense, besides just turning it on, turning it off, and typing into it or running things, playing games on it, sort of stuff, to where when you start running that program, if it starts malfunctioning and causing issues with your computer or your hardware or your software you already had built in, for me, most of the time, if something were like that were to happen, I'd end up having to reset my computer back to factory settings and then go through and re-update everything to current versions. That way I could get rid of the bad program and any issues that bad program caused, and then maybe leave a review kind of explaining that the program caused a bunch of issues with my software and my hardware, and I had to default back to factory settings and go through a lot of mess to get things working properly, and so I won't ever download that program again. I may even try to remember who the programmer was so I don't download any programs from that programmer. Um, Otherwise, yeah. It's kind of a thing right there and stuff. That way the programmer knows that there was an issue. They may reach out to you, they may not. I don't know. But anyways, moving on, which is both wonderful and dangerous. And that's what I was kind of getting at with that. C++ is designed to allow the programmer a high degree of freedom to do what they want. However, this also means that the language often won't stop you from doing things that don't make sense because it will assume you're doing so for some reason it doesn't understand. Um, I'm not sure where to go with that. There are quite a few different pitfalls that new programmers are likely to fall into if caught unaware. This is one of the primary reasons why knowing what you shouldn't do in C or C++ is almost as important as knowing what you should do. Um, I have been studying so far uh, a few code languages for the last 3 to 6 months, roughly. Now, there are supposedly some courses out there you can take to get a programming degree in 6 months. And I am not 100% sure. I honestly don't trust them myself because just from my research that I've done alone and stuff, there is a lot to understand with programming. I mean, what are they teaching you about what program? Um, what certifications are you going to get? How much time will you have to spend doing those things? I've heard of some people going through those classes and getting the certifications and everything, and um, I I know if some people have done it. I don't know them personally though, so I don't really know what they know. When I worked in automotive and stuff, I did know some people that went to school for automotive. Um, Depending on the school that they went to, though, was whether or not they knew what they were actually doing. One person went to a certain school that I knew. Well, they both actually went to a school that I knew about. One of them went to a school that I actually knew the teachers and knew how they taught automotive, and that person was actually pretty good with vehicles. But another person that went to another school that I was kind of iffy about uh, didn't know the basics because the only thing that they were teaching, they were not teaching hands-on. They were just teaching book material. Most of your education was going towards buying just the tools, which was required, and I don't agree with that. Tools are expensive enough as it is. You should be paying for the education and the hands-on training when it comes to automotive, not just the tools. Uh, Anyways, moving on. So we got a question here. What is C++ good at? C++ excels in situations where high performance and precision control over memory and other resources is needed. Here are a few types of applications that C++ would excel in. Video games, real-time systems, for example, transportation, manufacturing, etc. High performance financial applications like high frequency trading, graphical applications like simulations, productivity and office applications, embedded software, audio and video processing, artificial intelligence, and natural uh, networks. Now, I don't know enough about C++ myself yet to know how to get half that stuff to work. Obviously, with assembly language and stuff, you can activate anything in your computer, but I don't know anything about assembly language yet. Real-time systems like transportation, manufacturing, yeah, I might be able to write a program with those, and that's kind of what I'm currently working on learning how to do. Um, Whether it's a dispatcher at a trucking company that is currently tracking trucks, you got truck number such and such. I need a location for it, so then you got to use a GPS, which is probably a built C++ program involved. Manufacturing, a lot of your machines and stuff use some sort of code or computer for robots to operate, which is very easy for with C++. High performance trade, yeah, you can track trades, account, amounts, numbers, whatever. Graphic applications, I know it's possible, just haven't gotten into the graphic applications yet. Productivity, yeah, that one's easy to track. Most of these languages and stuff, though, I could not write programs for them yet. That's why I'm doing this all. In fact, this is pretty much my second time going through this material right here, which I'm hoping I'll learn a little bit more and have a better understanding of C++ once I get through all this. Audio and video processing, I have not gotten into that yet at all. And artificial intelligence, same thing. I have no idea on how it works yet. I'm hoping that when I get a really good understanding of C++, though, those are some things that I can get into knowing about as well. Um, Anyways, moving on. C++ also has a large number of high-quality third-party libraries available. Most of these libraries are probably created by C++. It's pretty much just another program to run with the current program you're building, um, which can shorten development time significantly. Yes, because that way you don't have to write the program for it to do. But again, you have to understand the libraries and how they work in order to use them and use them to their full benefits. Another question. Let me get a drink real quick. My throat's getting dried up. So, another question here is, isn't C++ dying? And the answer to that is, some people would say yes, some people would say no. Some people don't even like C++ at all. Uh, it originated from B, B turned into C, C turned into C++. and another company decided they want to remake it in their own image, so they built C Sharp, I believe. But is it dying? According to this right here, nope. Surveys consistently indicate that C++ is the second or third most popular compiling language behind Java and sometimes C Sharp, and just ahead of C. Now, I don't know when this material was last updated, so I couldn't tell you if that's currently accurate or not. This material may be a year old, 2 years old. I have no idea. So that statistic can end up varying back and forth. I do know that it is used quite a bit for a lot of different things. So games, applications, software, etc. Anyways, so second or third most popular compiled language and the fifth or sixth most popular language overall, excluding HTML, SQL, and shell script languages. Yeah, I'm sure there's a lot going on behind the scenes of HTML and SQL. They may even have some part of C, C++, C Sharp, whatnot embedded into them, but I do not know. Again, this is kind of me just discovering a lot of things and learning a lot of things, so um, and just kind of sharing that journey with you. C++ is one of the most popular languages for learning to code when owning to the uh, abundance of teaching resources, the large community, and the number of college courses that teach it. With language updates every 3 years, a huge number of useful third-party libraries, and dominance in the ever-popular video game industry, C++ continues to thrive. Last question here is, do I need to know C before I do these tutorials? The answer to that, nope. It's perfectly fine to start with C++. Knowing C can kind of give you an understanding of some of the already implemented stuff in C++, because some of the stuff in C can be used in C++ as well. Not everything, though, that I understand of. And well, teaching uh, everything you need to know, including pitfalls to avoid along the way. Once you know C++, you should be pretty easy. It should be pretty easy to learn standard C if you ever have the need. These days, C is mostly used for niche use cases, code that runs on embedded devices, when you need to interact with other languages that can only interact with C, etc. For most other cases, C++ is recommended. Um, so yeah, I do know that C or B or C++ was not the first languages out there. So yeah, I'll just leave it at that. Let you come up with your own assumptions, your own opinions about all that sort of stuff. So we're just gonna move on and keep going through this. Introduction to C++ development. So once I get through a little bit of this, I'm gonna go ahead and cut the video off. I'm not gonna go through all these steps right away. Um, but let's get started on this. Before we can write and execute our first C++ program, we need to understand in more detail how C++ programs get developed. Here is graphic outline. A simplistic approach. So step one would be define the problem to solve. Step two would be design a solution. Step three, write a program that implements the solution. Step four, compile a program. Step five, link object files. So if you have multiple files, make sure they link together. Step six, test the program. And then step seven, debug, starting with the compile if you have any issues. Step seven may be kind of an optional thing, but yes, it's probably a good idea, even if your program works properly, to go back through it and debug it, check it, if there's any improvements you can do. Um, but testing the program is where that's going to take place. So you're going to want to do all kinds of different tests on your program to begin with. Give me a second. So for advanced programmers out there and stuff, this is probably nothing new. For beginning programmers like myself, uh, learning all this stuff kind of helps you to really understand what you are trying to do, how to get it to work on multiple different platforms, but you also have to understand those multiple different platforms as well. So, like I said, a huge universe of things to understand here, and also there's still a huge universe of things to learn, explore, and discover. So, just because all this stuff exists doesn't mean it's not possible to improve upon it. There's so many things out there that our imagination can think of that we have not figured out yet, in my opinion. Anyways, step one. So we're gonna go through these steps right here with more detail. Define the problem that you would like to solve. Uh, Actually, I think we'll go ahead and stop right there and stuff, and we'll get into depths on these right here because there's 7 steps, obviously, um, but it only goes through 3 of them in this one right here. They may actually include multiple things in these steps, but yes, we'll pick up in the next video on defining on these steps right here. So again, if you like the video, click the like button. If you have any questions, anything you want to add to it, anything corrections or whatnot and stuff, uh, leave them in the comments. I have no problem with that sort of stuff in the comments. Again, I am not doing this to teach anybody anything. I am doing this to learn myself, using these videos to help me kind of stay awake while doing this, which is a solution I have found. Otherwise, I would be sitting there nodding off every 5 to 10 sentences that I read off. Not to mention the fact that reading it out loud kind of helps me to understand it. Yes, I'm kind of reading it fast and I don't understand all of what I'm reading, but that doesn't mean that later on I won't better understand it uh, the further I get into this. And yes, I probably will end up going through this another time or again in the future, as probably I will with W3 Schools again. But there's a lot of information to cover in this, so like I said, that'll be the end of the video for this time around, and I will pick up on the next video right here defining the problems that would you would like to solve when writing programs. So I will catch you next time.